Have you ever wondered what lurks in the deepest, darkest corners of our oceans? Down in the abyss, where sunlight never reaches, strange and wonderful creatures exist, and many of them are giants. This phenomenon is called deep-sea gigantism, and today, we're diving deep to uncover the science behind why these animals grow to such colossal sizes. Imagine a world of crushing pressure, eternal darkness, and freezing temperatures. It sounds harsh, right? But for some organisms, this extreme environment is the perfect place to thrive and grow enormous. So, grab your virtual submarine gear, because our journey into the abyss starts now. One of the most famous examples is the giant ice. You might know its smaller cousin, the roly-poly, or pillbug, from your garden. While a pillbug is tiny, a giant isopod can grow up to the size of a small dog. They're like something out of a science fiction movie, crawling along the ocean floor, thousands of feet below the surface. Then there's the giant squid, a legendary creature that has inspired myths for centuries. It can reach lengths of over 40 feet, with eyes the size of dinner plates. And let's not forget the Japanese spider crab, whose leg span can stretch up to 12 feet, making it the largest arthropod on Earth. So, what's the secret behind their massive size? Scientists have several fascinating theories, and it's likely a combination of factors. Let's break down the first big idea. Bergmann's rule. This ecological principle, originally observed in land animals, suggests that within a species, individuals in colder climates tend to be larger than those in warmer climates. A larger body has a smaller surface area to volume ratio, which means it loses heat more slowly. The deep sea is incredibly cold, with temperatures hovering just above freezing. For an invertebrate, a larger body size means a slower metabolism. They metabolist, grow slower, and live much, much longer. This extended lifespan gives them more time to grow, and grow, and grow. Think about it like this. In the cold, slow-moving world of the deep sea, life is a marathon, not a sprint. A slower metabolism is a huge advantage. They don't need to eat as often, which is great because food is incredibly scarce down there. These giants are masters of energy conservation. A giant isopod might go for years without a single meal, patiently waiting for a large food fall, like a dead whale, to drift down from the surface. When that feast finally arrives, they gorge themselves. Their slow metabolism allows them to process that massive meal over a very long time, fueling their slow but continuous growth. Next, let's talk about pressure. The pressure in the deep sea is immense. At the bottom of the Mariana Trench, it's over 1,000 times the pressure we experience at sea level. It's like having the weight of 50 jumbo jets stacked on top of you. You'd think this would crush any living thing. But deep-sea creatures have adapted in incredible ways. Their bodies are mostly water, which is nearly incompressible. They don't have gas-filled spaces like lungs or swim bladders that would collapse under the pressure. Some scientists believe that this high-pressure environment might actually favor larger cell sizes, which could contribute to a larger overall body size. The immense pressure also affects chemical reactions and metabolic rates, potentially slowing them down even further and contributing to that slow and steady growth we talked about. Now, what about predators? The deep sea is a vast, empty space. While there are certainly hunters lurking in the dark, there are far fewer predators compared to the bustling, crowded ecosystems of shallow reefs or coastal waters. In many environments, growing too big can make you a target. But in the deep sea, being a giant can be a form of defense. If you're a giant isopod or a massive crab, there are very few things big enough to try and eat you. By growing to a colossal size, you essentially become the king of your domain. This lack of predation pressure removes a major constraint on size, allowing evolution to favor gigantism as a successful survival strategy. You can focus your energy on growing and reproducing instead of constantly avoiding being eaten. Another crucial piece of the puzzle is the oxygen content in the deep sea. While it might seem counterintuitive, the cold, deep waters can actually be richer in dissolved oxygen than warmer surface waters. Cold water holds more dissolved gas. This abundance of oxygen is essential for sustaining a large body. A big animal requires a lot of oxygen to fuel its tissues, even with a slow metabolism. The oxidonic environment of the deep sea provides the necessary fuel for these giants to exist. So, while life is slow, the resources are there to support massive growth, as long as you can find the food. It's a perfect storm of conditions. You have the cold temperatures and high pressures slowing down metabolism and extending lifespans. You have the scarcity of food, which favors creatures that can survive long periods between meals and grow slowly. You have a lack of predators, removing the don't get too big rule, and you have enough oxygen to support a large body. All these factors combined create an evolutionary pathway where getting bigger is a winning strategy. The bioluminescence you see in many of these creatures isn't just for show. It's a vital tool for communication, hunting, and defense in the total darkness. For a giant squid, its huge eyes are perfect for detecting the faint glimmers of light from prey or predators far away. For the Japanese spider crab, its long legs allow it to cover vast distances on the seafloor in search of scarce food. Every feature, including their size, is a masterful adaptation to one of the most extreme environments on our planet. So, deep-sea gigantism isn't just a quirk of nature. It's a brilliant evolutionary solution to the unique challenges of life in the abyss. These magnificent giants remind us that life finds a way to thrive in even the most unforgiving corners of our world. They are a testament to the power of adaptation and the incredible diversity of life on Earth. There is still so much we don't know about the deep sea. Every new expedition brings back images and data of creatures we've never seen before, pushing the boundaries of what we thought was possible. These gentle giants of the dark are one of the last great mysteries of our own planet, a reminder of the vast, unexplored world that lies beneath the waves. Thank you so much for joining me on this deep dive into the world of ocean giants. I hope you found it as fascinating as I do. If you enjoyed this video, please give it a thumbs up and consider subscribing for more adventures into the wonders of science. Let me know in the comments which deep-sea creature you find the most amazing. Stay curious, and I'll see you in the next video.